When you bite into a crispy fried chip, the journey inside your body begins instantly. 1. In the mouth. Breakdown begins. As you chew, your teeth break the chip into smaller fragments. Saliva mixes in, starting the digestion of carbohydrates with an enzyme called amylase. Traveling down the esophagus. The crushed chip travels down your esophagus, pushed by smooth waves of muscle contractions known as peristalsis. In the stomach, fat meets acid. In the stomach, powerful acid and enzymes break down proteins and soften the fried coating. But the oils, the main component of fried chips, take longer. They float, forming droplets that the stomach slowly prepares for the next stage. As the mixture enters the small intestine, bile from the liver and gallbladder emulsifies the fats, breaking them into smaller particles. Pancreatic enzymes then finish the job, freeing fatty acids and carbohydrates so they can be absorbed. Carbohydrates from the chips are absorbed quickly, entering the bloodstream as glucose, delivering a fast burst of energy. Fatty acids enter the lymphatic system and eventually the blood, where the body can use them for fuel or store them for later. The high salt content of fried chips absorbs water into the bloodstream, increasing thirst and making the kidneys work harder to maintain balance. As the partially digested fried chips pass from the stomach into the small intestine, they enter the most important portal of nutrient extraction in the entire human body. Here, the inner walls are lined with millions of tiny, finger-shaped projections called villi, and each villus is covered with even smaller hair-like structures known as microvilli. Together, they form what is often called the brush border, a vast biological landscape specifically designed to absorb nutrients with stunning efficiency. These structures are not passive. The microvilli release enzymes that continue the final stages of digestion, slicing starch molecules from the fried chips into simple glucose, breaking fats into fatty acids, and converting proteins into amino acids. Every second, billions of tiny chemical reactions take place along this surface. Because fried chips contain refined starches, the resulting glucose molecules are absorbed immediately. Transport proteins in the villi cells grab glucose and shuttle it into the bloodstream with incredible speed, causing a noticeable spike in blood sugar. Within minutes, this sugar surge signals the pancreas to release insulin, a hormone that helps move glucose into cells for energy. This rapid absorption is part of why fried chips can give a quick burst of energy, followed by a slump when blood sugar drops again. But the fate of the fats is far more complex. The oils used to fry chips have been broken down into fatty acids and monoglycerides, but unlike sugars, they cannot simply slip into the bloodstream. First, they must be packaged. Inside the cells lining the villi, these fatty acids are reassembled into triglycerides and bundled into microscopic transport spheres called chylomicrons. These particles are too large to enter blood capillaries, so instead of entering the bloodstream, the chylomicrons are absorbed into the lymphatic system, a branching network of vessels that usually carries immune cells and excess fluid. This detour means that fats from fried chips take the scenic route through the body, traveling slowly upward toward the chest, where the lymphatic system finally empties into a major blood vessel near the heart. This delayed entry is why high-fat meals can impact the body for hours after eating, long after sugars have already been processed. Other nutrients, minerals, additives, and salts. Alongside sugars and fats, the villi also absorb sodium and any minerals present. The sodium content in fried chips is particularly high, and its rapid absorption increases the salt concentration in the bloodstream. This triggers thirst, stimulates kidney adjustments, and influences blood pressure. Below the surface, clusters of immune cells constantly monitor what passes through. Every molecule is inspected for safety. This silent surveillance helps detect harmful pathogens and maintain the balance of the gut environment. By the time the digested chips leave the small intestine, nearly every usable molecule has been extracted. Sugars rush through the bloodstream, delivering quick energy. Fats travel slowly through the lymphatic system, providing long-lasting fuel. Salt disperses through body fluids, altering hydration and balance. Together, these absorbed components set the stage for the next phase of metabolic processing. With refined starches and simple sugars, fried chips cause a mild but noticeable spike in blood glucose. In response, the pancreas releases insulin, a hormone that pulls sugar out of the blood and into your cells. But insulin works quickly. A rapid rise is followed by a gentle fall, which can trigger hunger or cravings. With refined starches and simple sugars, fried chips cause a mild but noticeable spike in blood glucose. In response, the pancreas releases insulin, a hormone that pulls sugar out of the blood and into your cells. But insulin works quickly. A rapid rise is followed by a gentle fall, which can trigger hunger or cravings. Fried chips are usually loaded with sodium. High salt concentration pulls water into the bloodstream, increasing fluid volume. This makes you thirsty and forces your kidneys to work harder to restore balance. The liver receives fatty acids from the chips and must decide what to do with them. Use them for energy, send them to muscles, or store them as fat. If chip consumption becomes frequent, the liver becomes more efficient at storing fat, especially around the abdomen. Your gut microbiome, trillions of bacteria, react strongly to fried foods. Some species thrive on the oils and starches from chips, while others diminish. A shift in this balance can affect digestion, mood, inflammation, and long-term metabolic health. Within 30 minutes, chips deliver a wave of quick energy. Within an hour, blood sugar begins to drop. Within 3 hours, the stomach empties and hunger may return. Occasional indulgence is harmless, but regular fried chip consumption can lead to increased LDL cholesterol, higher blood pressure, insulin resistance, excess visceral fat, reduced dopamine sensitivity, chronic inflammation. The body adapts to what you feed it, and it always remembers. So the next time you reach for that crunchy golden bite, remember, inside your body, fried chips set off a surprisingly complex cascade, a blend of chemistry, hormones, digestion, and psychology. A small snack with a very big journey. Don't forget to like, subscribe, and share.